I'll spotlight you for everyone.
Okay. Hey, everyone.
And thanks, Dan, for agreeing to join us. I think it's a great opportunity for our students to kind of see what's happening in industry. I think I've kind of told the students your background a little bit. I think you graduated from UF in 06, is that correct?
2005, I think.
05. Okay,
05,
so
yeah.
a year earlier. I think we crossed paths a little bit at Harvard GSD. You graduated in 2010 and then just went on to SOM, has been there ever since, right?
Yeah, since 2010.
Yeah, okay. Do you want to give us a little bit of background or besides that?
Well, thanks, Lee, and it's good to see you and everyone. Yeah, I graduated from UF 2005. I think some of the same professors are still there, Charlie Haley and Donna Cohen and others.
Yes.
Back then, and I think, Lee, you would probably know better than me about this, because my experience at UF was more based in more of a craft and sort of a manual process in terms of design. You know, we had a lot of hand models and a lot of sort of handcrafted drawings. So it's great to see, you know, this, not only this class, but Lee, you know, it's great to see you advancing and pushing us forward at UF. So in a nutshell, 10 years at SOM, almost 11 actually. And it's been a learning experience at SOM. So, you know, I'd like to share a few projects and talk about the design process in terms of how we leverage technology, specifically Grasshopper, Revit, and other techniques to actually realize projects at a very large scale. Admittedly, I would say that when I graduated UF, I didn't necessarily see myself moving on to SLM. I think there was sort of a draw that I had to working at a smaller, more boutique firm. But, you know, as we all know, 2008 financial crisis happened. Many things changed for many different people. I ended up at SLM and I ended up learning much more than I could have imagined. So I'm going to take you on a little bit of a summary of our process and what it's like to work on very large projects. And I like to keep this conversationally. If you don't mind, if there's questions, please just put them out there.
Yeah, of course. So yeah, if you guys have questions or you guys see something that you want to ask about, ask away, okay?
So you may know SLM as sort of a global firm, you know, with Burj Khalifa, the World Trade Center, Al Hamra, Canyon Tower, other icons around the world. You know, the great thing about working at a firm that's this large is that you get to learn about different cultures because you work in many different contexts. And when it comes to having a global studio or a collection of global studios, it's really important to actually be able to find ways to share information rapidly and in a coherent way. So when we talk about setting up models, we have to set up a process in which if we're working on a project in Shanghai or in China, we can fluidly share that same model as the team comes in during the morning and we leave for the night. So a lot of the things that, you know, we recognize, or one of the big things that's important to recognize is that communication is key. In my personal experience, I started working abroad, specifically in Guiyang, China in 2014, I believe, with the project that's on the left. This is the Guiyang Cultural Plaza Tower. It was designed to be 521 meters tall. It was the first time I was fairly junior, but it was the first time that I was allowed to sort of take trips over there, meet with the client groups and give the presentations as a senior designer. So I learned a lot in terms of what it takes to create a tower of this scale. The one sort of myth that we all, at least in my mind, I had at the time was that, you know, the burden is on a single person. But the reality is, to be able to design a tower of this height, it takes an incredible team and a very large team of many different people working in the same model together. So it's a group effort, and you have to have sort of a collective sense of design direction. The tower that's on the right is the Hangzhou Wangqiao Center. And I'm going to focus on this because it also required a lot of sort of collective thinking and heavy use of parametric tools. You can see that formerly both towers are quite complex. The geometries required us to have a very clear process in Rhino, Grasshopper, and Revit to get them realized. Now, I'll say the tower on the left was put on hold indefinitely, but the tower on the right is actually in construction now. It should be finished early next year.
Dan, can you really
Yep.
quickly give us a sense of like how big these teams are and kind of how
Yeah.
many people were involved?
Yeah, so for GCP, so let me just say that the tower on the perspective here is a little different. The tower on the left was designed to be over 500 meters tall, while the Hangzhou Wangqiao Center on the right is a little below 300 meters. I would say for what's on the left, it was probably more than 10 to 15 people, both technical and design architects, excluding probably or including some engineers, and probably around 8 to 10 people for the tower on the right. And the way, if you would have been talking about this maybe 15 years ago, Lee, the teams will be much larger.
Yeah.
But the reason we can condense the teams and we can actually achieve buildings at this scale is because we're leveraging technology in a certain way to be more efficient.
For sure.
Also, I do have some experience in the Middle East. You may or may not have seen this, but it was circulating the blogs. Burj Jumeirah in Dubai. You can also see quite complicated geometrically, and it did require the same process for the towers that were mentioned from China. So, the key is, like I showed you that global map, we don't work in silos because it's just not possible. Like not one single person or small team can actually realize these projects at this scale. So we have to really invest time in figuring out how we can share resources together and consolidate. And that's important because your teams are going to be large. And as a senior designer, my responsibility is to lead the design team. And when you have so many different team members plugging into the same model, you have to establish sort of the rules of operation, how you're going to approach realizing some of these studies or different options that might come up. It all has to be sort of laid out very clearly. So we like to do like a little roadmap at the beginning of each project, understanding where things will externally feed into the model, eventually making its way into Revit. So in this case, this is the diagram of the Hangzhou Wangqiao Center in one of those China towers, and you'll see that the rendering platforms vary. So it's, I know you were showing Lumion, Lee. We use, maybe this is a little bit outdated because this is from 4 years ago. Keyshot, V-Ray, Modelo, 3D Max. We had some studies in Maya, and eventually it all makes its way into the Revit model. Yeah. So we'll talk about this in a little bit more detail because there's a lot of interesting aspects of this tower that can be described to you, and I think it might be interesting for you. But before that, I just want to share with you this, Lee, and this might be interesting for your class. There's a couple articles that I wrote with Neil Katz, where we're trying to describe the history of SOM and how SOM historically has leveraged technology to realize some pretty, remarkable buildings that are quite iconic now. If you're interested, here's a link to this article. This was originally printed in a book, but we managed to get the PDF on our website if you want to just take a quick read. And there's more of a synopsis or summary of that article in a conversation between me and Neil, where we just describe, the history and why it's important to really be forward thinking when it comes to the design process.
Oh, great.
And in that article, we talk about the 1960s and what we were doing with preliminary structural analysis, which the John Hancock Tower in Chicago was actually analyzed structurally with some of these really, the first analytical structural programs that existed actually. Same thing for Hodge Terminal. And, nowadays what we can do, this is from a few years ago, but this is a Kathleen Grimm school, the first net zero building in New York State. This really relied heavily on a parametric model that was using DIVA analysis to sort of shape the PV panels, because net zero really means the building consumes zero energy. So it has to be energy positive. And it works quite well. It's built and without Grasshopper, Diva, or that kind of analysis, not even possible. And then some other towers that never got built, but were interesting geometrically. This is the Lotte Super Tall competition. A really kind of interesting diagrid structural system. But
I remember modeling that tower for Farshid's book, actually. Yeah. Some of these diagrams.
Yeah, unfortunately, the tower that did get built is from KPF.
Yeah.
But when you think about, Lee, you might have experienced this. The difficulty of this tower is the diagrid structure has to align with the floor plates.
Yeah.
So, because otherwise the diagrid has no sort of diaphragm action. So that in itself, the fact that these nodes have to hit floor plates, and you guys probably don't know this now, but you will in a few years if you start working on projects like this. The floor plate spacing in a tower of this height is never continuous or constant, because you have mechanical floors, you have things that change the floor-to-floor heights. So catching that and deforming the structural system to actually meet the nodes, super complicated. So let's talk about this. This might be interesting to you. It's something that's actually under construction. If you go to that article, I'm just going to take you through an animation that a very talented team member that worked on the Hangzhou Tower, he put this animation together to summarize his process. He managed the geometry for the team. And towards the bottom, we have a little clip. And I'll just play segments of this and kind of pause to give you some insight as to what we're looking at. Lee, can you see this animation?
Yeah.
Okay. One thing to note is that this animation was actually made in Grasshopper. In other words, it was animated in Grasshopper. I still don't know exactly how he did that, but it's kind of remarkable. So he's going to highlight a few things that we're going to discuss. The panelization strategy, the lobby and structural system, and then we'll look at the actual definition. So like I was mentioning before, the floor plates for a tower this height are not constant. They're not always going to be the same dimension. And that happens because of a couple of reasons. Towers of this height, usually around the world, are most likely mixed use because they're designed to bear the market, the future market, and not all just be one program type. So what that means is that typically there's a residential or a hotel hospitality component on the top. And the lower stack most likely will always be office. And why does that make sense? Well, economically, the lease span means, from the core wall to the perimeter of the building is your planning space. The lease span, if a tower this height tapers, becomes smaller towards the top, those smaller floor plates are ideal for residential program, for apartments, for hotel rooms, all that. Towards the bottom, the floor plates are larger, ideal for, office. Typical offices could be boutique offices or larger, financial firms that like big floor plates. So what he's done here is created a Grasshopper definition that can allow us to create the necessary floor plates with the necessary heights according to whether it's an office program, like office floor heights are 4.5 meters floor to floor, or if it's hotel, which is 4.2 or 4 meters tall. So we can vary that and we can control that with the definition. Also, you might see he's put in mechanical floors and other things that can help him adjust the stack as we modify the form. Now, can you imagine doing this by hand, manually? I mean, it just seems so impossible. It would just take so much time to iterate because you'd have to restack the whole thing over and over. So here, these are all in metric dimensions. He's adjusting MEP floors 6 meters, and he's adjusting all the floor heights by that controller. So this is something that we like to call the cookie sheet. And this is critical because typically a tower, let's just imagine a tower that's just an extrusion from the bottom to the top, does not change in dimension. Well, one of the things that the reasons you don't want to do that necessarily is because the lateral wind loads towards the top of the tower are going to be so strong that you're going to have a lot of unnecessary structure and bulk at the top of the tower. So tapering the tower naturally gives you more efficiency. In this case, we not only just taper the tower, but we designed a tower that has a very sinuous and curvilinear form, which was designed and optimized structurally. Well, the problem with that is if you show this design to a client or a commercial developer that's interested in maintaining these healthy lease bands, these planning dimensions that are going to actually be economically viable for a tenant, well, the floor plate has to make sense to them. So in other words, you can't have pinch points because your geometry is constantly changing and the relationship of the core to the perimeter is changing. So at no point can you compromise the lease bands, because if you do, you're just creating unusable, unsellable space. So the big reason the cookie sheet's so important for a tower with this complex geometry is because you need to be able to defend the fact that there are no significant pinch points, like there would be below a limit that is tolerable. So in other words, every floor plate has to work, and you can demonstrate that with this cookie sheet. Let me just play a little bit more of that. So here you see, we're identifying the 8.3 was the smallest dimension, the lease span here, but it was okay because it was actually for a boutique office tenant, which they don't mind being closer to the glass and not having a lot of planning space. And a big thing that we do with Grasshopper when we design towers is also calculate the floor efficiency. This is the basic one, which is just the basic core outline to the perimeter of the tower. And usually for a mixed use tower, you want to be in the high 60s to low 70s. But the beauty of the Grasshopper definition is that we can track all that dynamically. So as we change the tower and adjust the areas, everything gets updated and output to a spreadsheet. Yeah, here's the output. This is incredibly useful because if you work on these projects in the future, you'll start to track things like this. Every floor plate, its floor height, its efficiency ratio, the core area, the net area, and basically the program type. This obviously will help you move the process forward with engineering to calculate, the elevator loads and everything else in terms of how people will actually use each of these levels. He also did a visualization with a kind of a heat map for the lease bands where you can see the pinch points in red. Towards the top doesn't matter because it was a hotel, so they need the smaller spans. And then you see that with this Grasshopper model, we actually interface directly with our engineering group. So SLM is not just architects, we also are engineers. And we fed the model directly into their Grasshopper model. And they did some E-tabs analysis and other things that eventually made it into the Revit model as a consolidated model. Then we also have sustainability engineers, we have mechanical engineers that did a CFD analysis, and they actually discovered that these edges, by being slightly curved and by the varying form of the tower from top to bottom, actually helped optimize pedestrian comfort. So in other words, when you think of a tower, there's a lot of wind loads that hit the tower and they create downdraft. I'm from Jacksonville, and if you want to experience what I'm talking about, just go downtown and go to some of those towers along the downtown area. There's heavy downdraft some of those streets. It's because those towers were not designed with this kind of analysis. And now we can do that. We can leverage the Grasshopper model. We can feed it into these other platforms to actually do this analysis and really create this sense of clarity. So when we were doing that, we discovered that the more we actually rounded the corners, it created actually a significant impact, and it helped us optimize the tower more efficiently. So that's pretty much the video, and I can just share with you the remaining slides, Lee, so we can make this kind of a discussion.
Sure, yeah.
So this is a visual mock-up. It's about 3 stories tall. It's sitting in a backlot around Shanghai. The one thing I would say is that, having seen it in person, we were actually studying the grasshopper output in VR extensively, trying to get a sense for scale, because as you all know, the lack of a physical model or some kind of tangible sort of sensibility to what you're producing is when that's lacking, you have the potential to lose yourself in the process, right? So when I first went to see the physical mock-up, the visual mock-up, it was sort of a moment of surprise and relief. Because on the one hand, I didn't expect the panels to be this large or the joints to be of this dimension and all that. Having looked at the details extensively and looking at the 3D model, you don't associate it so directly. But on the other hand, a sense of relief, because, I saw how we were able to figure out these difficult situations through our panelization strategy. You can't infinitely subdivide the glass. At some point, you have to make a decision to have a larger glass panel because you can't create a shard of glass. So all these little moments of resolution and problem solving were self-evident in this visual mock-up, because these are little geometrical issues that you will encounter with projects of this scale, and seeing it in person, is sort of a big relief. So it's currently under construction. You can see the podium steel is pretty much topped off. I think they have the core up to level 24, but you may be seeing more pictures of this somewhat completed later this year, because it's proposed that towards December, most of the cladding will be up. So you get a sense of the tower's form much more than it is now. But you can see, they leveraged the structural engineers and actually our consultants in China. They leverage our grasshopper model to recreate not only the structure, but also the panelization standoff points. So the points where the panels would attach onto the floor slabs. All that was based on the model that we initially set up. And we were able to give them all that information so that they can manufacture all the metal panels correctly and all the glass panels. Now, I will say that even though the tower's appearance is somewhat, it looks like it's curvilinear and it's complex, there's not a single piece of curved glass on this tower. I would say during concept design, there was, but there's enormous cost implications. And if you actually want to get something realized and actually built, you have to optimize it. So we went during the ST phase of the project, we heavily studied manipulating the tower's geometry in such a way that we could absorb the turns in the geometry within the spandrel panels and not have a single piece of curved glass. So it's all flat glass.
Can you maybe explain what spandrel panels are?
Yeah. So you'll see here that this is a spandrel area, of the enclosure, and it's basically the space that is left somewhat blank because that's where your slab is, or that's where the makeup of the floor plate. Because you guys know, you're studying now that there's much more thickness and dimension to a floor slab than just concrete. There's mechanical systems and everything that makes up there. So in China, there's actually a really good building regulation that mandates access to fresh air for all commercial office space. Not necessarily the case here in the US yet, but you can see that coming given the current health crisis. Well, what that means is that you have to have access, be able to open or facilitate access to fresh air from every single point within the floor plates of the office space. So if you know what that implies, well, that could mean that you will have a window frame on the facade. which is not attractive. Like having a commercial tower with residential looking window frames is not something that you think, aesthetically is good design. So what we designed here, and I wish I had a detail of this, but we actually designed this spandrel in a way that there's a kind of a flap or a little flap along the floor edge that is actually a ventilator detail, that when you open it up, fresh air can come in through this area in the glass below and actually come into the building. So I know it's kind of unclear because it's hard to describe that without the drawing, but that's kind of what you're seeing. If you look at the visual mock-up, it's a little bit more clear. So here on the right, you'll see that the glass, there's a little gap. And the ventilator detail that I'm talking about is behind the glass here. So air can come in because of negative air pressure and how high you are in the building would come in through there and into the inside the building. So that again was also studied extensively with the mechanical engineers because they at first didn't think it was going to work. But that's why the tower's expression is this way. These louvers are designed to actually create some amount of protection, so not kind of everything can fly in there if you open up that ventilator detail. So yeah, there's a lot that went into the design of the facade, but I guess once we see it being clad later this year, Lee, I think it's going to be a lot more easier to understand it because the renderings only speak in a very specific way about the building. I think it's going to be important to see how the glass reacts with the sunlight, the different angles that are unexpected. If you look at these two renderings, this rendering here, this is the one that we always had in mind, and we did have a physical model of this in the office, so we knew the different angles and all that. But we realized very quickly that this view of the tower was going to be the primary view that everybody got the first impression, because when you're in Hangzhou, there's a tunnel, and once you come out of the tunnel to this area of the city, that's how you approach it. You're on the right lane, and you look at the site from this angle. So it's kind of a moment of discovery. So there's going to be a lot of those kind of moments of discovery, I think, later this year, once we start seeing the cladding, being placed on the tower, and once we see it being topped off. I think the last comment I would say, Lee, is I've given these talks in different ways, Lee, to different audiences. But one thing that I think is provocative to think about is the nature of the design process, the space that we design in, and how it's changed due to the tools that we use. So like I said, when I was at UF, I don't know how it is now, and I'm sure it's great, but we, I wasn't allowed to touch a computer until like the second year in. We were forced to do everything by hand, which was good because it teaches you to understand things in a very tactile way. And I think that's good. It helps you compose things and think about things critically. Well, if you think about the way that, this is 1976 SOM Chicago, these large areas where they would have giant drawings, and it would take you probably a couple days just to produce your sheet. So if it takes you that long to produce that drawing, you're going to invest a lot of time thinking very critically about what you're drawing, because otherwise you're wasting days and hours. Think about that moment in time, Lee, and now we can think about, where we are now. 2017, Shanghai, this is our Shanghai office. How closely people are spaced together, the workstations that we use to produce drawings and models. It's changed radically. I mean, and this is my workstation with one of our team members, Angela. She was testing out the VR model. This is from 3 years ago, I guess. We were testing things quickly with Enscape, sometimes Lumion, and being able to occupy the model somewhat physically was a thing. We can be inside that lobby. I wish I could share with you that animation, but it's confidential. But I would say that, now where we've come, work from home, I had to get a very basic 3D printer to print things, and now I use an iPad instead of paper. But think about the relationship of technology to the way we work now. I mean, I think it's just interesting to think how it's shaped, or the change in our technology has shaped our spaces and the space in which we work in. So I hope that was interesting, Lee, and everyone. It's just a few different takes on design and where we've come to.
All right, for sure. Maybe you have time for a couple of questions from.
Sure.
Sure. Okay. Let's open the floor to all of you. If you have any questions, whether I think, and we can make this a little broader, like it can be about the project, it can be about the workflow, or it can be about, if you want to ask about Dan's experience working in a large firm and how he got there, this sort of stuff. And I can start with a lead-in question. And this is a perfect frame for it. Dan, I think you know that in Miami there's the Zaha Tower, right?
Yeah.
1,000. I think there's some similarities in the exoskeleton. What similarities or differences does this tower have compared to that one?
Yeah, let me bring that up because I saw that comment before on DZine or our Instagram, and I just didn't kind of understand it. But let's talk about it because there's a fundamental difference. And I'm a big, I think Zaha Hadid, the work has shaped me personally. That I'll be honest from that point. It's been one of my most influential sort of points of reference, aside from others. But having said that, fundamentally different things. The one thing I didn't describe, and I could probably share this from another project, is that this tower is shaped by its structure. So in other words, the whole tower is like a giant diagrid. So what does that mean? That means that those are mega columns. And the reason you do a diagrid is because when you want to resist lateral loads, it's easier to do it with a diagrid than it is with a straight up typical system. So the tower's shape is not just invented, it's an optimization of a really basic structural idea of creating a diagrid that eventually shapes the tower and gives it its form. This building is not a diagrid. And I don't know if these are the most optimal structural lines that you could have designed. So I'm not criticizing it, but it's not a structural idea. So at SOM, I guess I could say, Lee, that the one thing that SOM that we value, and over the years, you might see this in buildings like the John Hancock Tower or Burj Khalifa in Dubai, or even this tower, is that because we're architecture and engineering together, we value the purity of the idea, of a design idea that is not just architecture for the sake of architecture or structure for the sake of structure, but it's integrated as one holistic idea. So the design expression of this tower on the left is based on a structural principle, and it's not just shapes, it's actually structure, if that makes sense.
Mm-hmm. Is the diagrid structure basically kind of steel structure and then cladded, or what's the construction type?
Yeah, so it's remarkable what you can do nowadays. It's actually CFT, concrete filled tube. So you might see it in these pictures. I think we could see it in. Yeah, so these are steel tubes that are filled with concrete for weight purposes and for greater strength. But what's remarkable about building technology, and this is not just in China, but it's across the world, because it can phase this out using advanced planning, whether it's using CATIA or other tools that can help you plan things ahead. They actually built this tower from the top down. So meaning that they put the piles when there was no excavation done yet. They drove the piles all the way down, and then they started digging down and simultaneously building temporary slabs for all the basements. Kind of a crazy thing, but this is how the tower gets built so fast. You know, it was designed, we designed this tower in, we won the competition in early 2017. We went through a year or so and a quarter of design, and they started building this well, they started the excavation and the foundations 2018 or late 2018. So it's been a couple years already, and they slated to finish it next year or later this year, early next year.
So about, let's say 5 years overall.
Yeah, pretty much.
Yeah.
And, you know, that's the thing that's kind of, you know, if you were involved with residential architecture, which I'm sure many of you have interned for firms like that, you know, your sense of, you get a return very quickly because it takes so much to build a house. But for a project this scale, you have to have a lot of patience to finally see it come out of the ground and finally get clad, you know, and all that. So it just requires a good amount of patience, but it's well worth it because, you know, buildings like these are necessary for cities across the world. And, you know, it's going to be something that hopefully people will appreciate in the future.
And this is also in China too, where like the speed of construction is, and let's say, you know, approvals processes are much faster.
Yeah. And actually the irony of all that is that in China, they have some of the most restrictive building codes of any other place around the world, which is not something that people think about. And look, you know, the world's a complicated place, right? So working in different contexts, you have to learn different things, and you have to know how to navigate economic and socioeconomic differences and all these things. But you do learn a lot. And for an economy that's growing that fast, and Hangzhou is an incredible city, it's the first time I ever learned that you can actually build a building foundation in its basements from the top down. I mean, it's just kind of crazy. But apparently you can do it. So you learn something every time you go over there. This is what I want to share, Lee. I didn't share this with you guys during this meeting, but this is a whole sort of what I would call the design formation of the tower. So, you know, it's a very simple diagrid that we tapered, you know, to optimize for program. And then when you smooth out the taper, it just helps with your wind loads, because the wind doesn't, you minimize vortex action. So the wind doesn't actually affect your building as much. And, you know, it does have a pretty high window to wall ratio. So it's actually, even though it looks very glassy, you know, I showed you guys, I talked about the spandrel area and all that. It actually has a good amount of opacity. So it's fairly well performing in terms of energy efficiency and sustainability.
Okay, I think there was a question in the chat. What happens to the mock-up afterwards?
Yeah, unfortunately, they would tear it down. They recycle it. A lot of times, you know, these projects, they won't reuse those panels because they would have to recertify them. But they would have to recycle the glass and the metal panel. And a lot of these factories, if you ever go to one of these, you'll see that, you know, they have some of these mock-up performance mock-up testing sites in Miami. They have the mock-up side by side, and a lot of times they try to salvage what they can from one mock-up to reuse for another if it's possible.
Do we have any questions from the group?
Oh, sorry.
You can go ahead.
Sorry, I just had a question in the chat. I was wondering how long a tower like of this size takes to design, like overall around.
Yeah, well, let's just talk about maybe the actual design phase. So, and I'll be candidly, you know, when you pursue these projects, these kind of pursuits are difficult because when you're involved with these international design competitions, oftentimes you go after these towers, you get invited or you pursue it. You're up against, Foster and Partners, OMA, KPF, Herzog. I mean, you're not necessarily Herzog for this one, but I think Zaha was mentioned at some point, UN Studio. You're up against big names. And that pursuit, the length of that competition might be anywhere from 6 to 10 weeks. So just the competition phase. And within that, I'll say that, the one reason it was so important for us to leverage Grasshopper as a design tool, we were explicitly modeling, forms to find something. And then once we found it, we put it into Grasshopper to optimize it. That process took about 8 to 10 weeks. And then we had a design that won us the competition. And from that point on, it was about 1.25 years, almost 1.5 years of concept design, schematic, design development, and then construction documents. So it takes a long time, but a lot of things changed during that time. Actually, the very first idea for the tower is that if you were to see the concept design version or the competition version, the tower was dramatically tapered. It was actually quite striking, and it was about 30 meters taller. So it had to change because the client required more program area. We plugged that into the model, and we just had to change a lot of things parametrically.
Taylor, you had a question?
What was your starting position at SOM and what did you do before?
Yeah, so it's a good question because I honestly never thought it would end up at SOM, but now I can't imagine. So when I first started, I guess when I was going to UF, I was working for a residential firm, learning how to draw Tuscan columns or something strange. And I got an internship at Gresham Smith and Partners. They're based all over Florida, all around, all over the place. And that's when I started to learn a little bit more about planning. Even though I was working for healthcare and all that, I just understood how to plan things, relationships between surgical rooms and all that. And that kind of got me interested in thinking a little bit more just purely on design, but thinking about planning. I graduated in 2010, and I started at SOM as a designer. So I was a D level, and that was actually almost one step closer to the bottom of where you can be. And then over the years, I think the good thing that, and you guys will experience, and not just SOM, there's a lot of firms like us, don't be scared because of scale. We actually operate like a grouping of small little studios. And, if you go move on to grad school, you'll find a lot of your graduate school colleagues at firms like this. And it's just been a fun experience. I think over the years, it took a little while for me to actually become a senior designer. So in other words, lead a design team. That takes some time. But once you find the pivotal project that's going to put you in that position, you can take off from there. I was lucky to have this project because, to be honest, we had just learned that we lost a competition right before this. And the reason I like talking to you guys is because you guys are, UF. Hardworking, incredibly, dedicated, and barely sleep. So like that's how I got through SOM, because I came from UF, and of course, went to the GSD with Lee and others, but the foundation was the work ethic that I had from undergrad, because we were nuts. We would dedicate ourselves and build models all night and try to just get things done. And that work ethic paid off at SOM, because it meant that you were going to see it to the end. You're going to be the most dependable person on the team, to push the button or to send the email, whatever. So I think that dedication coupled with other experiences ultimately, gives you a leg up above the rest, because then you can emerge as a person who's always dependable, great designer, and you can be counted on. And now, so right before this, we had lots of competition in Japan, and we thought we won it. Honestly, we went over there, we presented, it felt like we sold them. We came back 2 weeks later, they told us we lost. Incredibly depressing, but this is what the design process is. It's not like we're going to win every project. So you have to get used to the pace of constantly pursuing, having the patience, and not fearing rejection. 2 weeks later, they told us we won this around this time because it's after Chinese New Year, and we took it from there. So, it wasn't like a linear story where I just jumped to the very top when I joined SLM. It takes time, but with the strong work ethic that you guys have, you can make it in any firm like that.
All right, more questions? Don't be afraid. Don't be shy. He's alumni. He doesn't bite.
Do you think it's better to specialize and become an expert in a specific area, or try to know the whole general process?
That's a good question, because maybe I should be more specific about how I emerged at SLM. I think, I'm not going to be like the older designer sort of patronizing you guys now with technology, because back in the day, but I will give you a back in the day story. Back in the day, V-Ray setups and all this stuff with 3D Max was incredibly complicated. You had to memorize settings, and you had to make your prefixes and presets, and you had to, when scenes wouldn't render in 3D Max with V-Ray or whatever, you had to like problem solve it. And it took a lot of time, and it took a lot of like memorizing things and knowing tips and all that. Now with Enscape and Lumion, forget all that, right? But when I first started at UF, I was drawn to that, using Mental Ray and all these old school rendering engines. So, and I don't know if Professor Mays is still there, but he was teaching that. And so I became kind of a renderer in a way. And it's because I liked it. I like images. I like photography. I like to paint watercolors, like by hand. So it felt like a natural progression for me to express myself with renderings. So I kind of became specialized in that. So when I got to SLM as a very junior person, I was just really good at rendering. So I can sort of create the visuals up to the point where I just started to create the content as well. So at some point I would operate like a renderer for the team, but then I became slowly the designer, and then I became the designer. I think that is different now because rendering engines are simplified. You have Enscape, you have Lumion. Everybody, it's kind of democratized. Everybody can create a nice image. I think it's important, even though you may not be a specialist per se, it is important to understand Grasshopper and what it can do, because you can extend yourself so much with having the ability to create tools that you can use for your design and not rely on somebody else to do that for you. So I think that's important, to have a firm understanding of Grasshopper as much as you can invest in it, because you will not rely on anybody if you have that control. And, you can create things that are not manually possible to do, like this tower, for example. I will add, Lee, to that question. Rhino 7 and sub-D modeling is a very powerful thing.
Yeah.
And I'm not saying we should all design organic shapes like this or whatever you want to call it, but it's just an incredibly liberating way to model, even though your geometry or your design sensibility might be different. So there's a lot to be invested there, not just Grasshopper, but in actual new forms of modeling, sub-D modeling.
which is I think in your roadmap earlier, I think you guys used Maya first, or I saw Maya in there, right? And so for us, it kind of replaces Maya to a certain degree. But yeah, we will actually cover some sub-D modeling later in the semester. Yeah. Are there other questions?
How'd you like your time at UF?
It was good. I guess it was some very memorable 4 years. Haven't been back since, but I made some incredible friends. I think you guys realizing now that you may not remain with everybody, especially if you move out of Florida. You know, I actually moved out to Atlanta. I worked for Max Scogg and Merrill Elam for a year before I went to the GST. So I made some other friends, but I think it was a good foundation. And I think if you want to go to other places, you'll find that the foundation that you get at UF is going to leave you in a very strong position. And there's only a handful of schools that are like that. You can put Ohio State in that list, you know, Berkeley, UVA, UF, maybe UT. There's only a handful of schools that are like that. Michigan. So, you know, I had a good time, and I always would relate my time at the GSD with UF because it's a strong foundation that you're getting.
Thank you. Any others?
There's a question about hand sketching. Is that right? Yeah.
Oh, yeah.
Yeah. So, Lee, this might be interesting to you actually, because, you know, like I showed that picture of my current setup where I'm tiny little space here in Brooklyn. You know, when I was in the office, and I will say, you know, it's unfortunate you guys have to go to school like this, but it's soon going to be over and we'll look past this, because I know you guys want to be in studio and it's a lot more fun. But when I was in the office, in the physical S1 office, you know, I was kind of old school. I would ask somebody to do a screenshot, print it out. I would sketch over it, and I would have trace paper, you know, the rolls of trace paper that are this big. I would cut those in half, like this big. I would go to the bandsaw, cut them in half, because I felt like I was wasting paper. I just want to doodle and do a quick sketch. So I'd cut the trace paper in half, and I would do lots of overlays. And I know everybody's fond, yeah, exactly. Everybody loves their sketchbook, but for me, just the way I am, I don't like nice sketchbooks or anything like that, because I like to iterate so much that I just destroy it. So I would do these sketch overlays, and then when I like something or I thought it was there, I would take a picture of it or hand it to the person and be like, this is the direction, let's move with this. So you can see how kind of backwards that process is. I'm doing hand sketching over a screenshot and then taking a picture of it. It's kind of backwards. Now, what I've learned to do over the last year is to replace my sketchbook trace paper with an iPad. And Morpholio Trace and all these applications that are out there. Now we communicate a screenshot through Slack, I sketch over it, and I send it back through Slack. So much faster and efficient. I would say that hand sketching is not precluded from this process. This tower was designed through a sketch. And a lot of the detailing, other areas of the tower were conceptualized by hand, but it was quickly translated into a grasshopper model and all that. So, you know, the starting point for me was not grasshopper. That's hard. Some people can do that, but for me and my team together, we like to work still communicating visually by hand, because it's hard to vocalize in words form, right? Yeah. And we also sketch in Maya and in Rhino. Like a little incomplete model can be the basis of a hand sketch, or it can turn back from 3D. You know, the iterative process is not linear. You go 2D, 3D, 2D, 3D, until you find it.
Yeah, I mean that's really well put. I think one of the things even in my sort of specialization as a kind of more digital oriented person, oftentimes with like design ideas and things, I literally ask my students to do what you did, basically print it out, sketch over it, right? Because I think there's a sort of freedom of thinking that comes with drawing by hand that is not necessarily what the computer is always very good at, right? And depending on the tool and things like that. But in terms of like complexity, managing data and all those things, those are things that the computer is very good at. And so kind of finding the right place to use the right tools, I think is the thing. It's not neither or, but it's really a combination.
Yeah, and Lee, that argument, when you and I were probably an undergrad, and people would have this kind of weird, very strange argument that super polished computer renderings were working in opposition of the beautiful handcrafted sketch, or I don't know, there's this kind of weird conversation going on there, and this strange conversation about just because something is highly crafted digitally, it precludes the handcraft or the hand touch or whatever you want to call that.
Mm-hmm.
I think that's an invalid conversation, my personal opinion, because it doesn't make any sense to me. Like you just said, the process can be very fluid, and it can move from an idea that you communicate on paper to a digital model very easily. And at least at SOM, the design partners that I work with, we always have something around us, because when we talk, we're like drawing at the same time on the screen now on Zoom, which sucks, not great, but so if this is my personal take. If anybody talks that way, I think they're missing the point, because the end result's always just the design, and its seed of generation or its seed of origin comes from a very messy place, and that messy place is the 2D, 3D realm of translating ideas that you have that are hard to model very quickly into three-dimensional space.
Yeah, and I think it's also goes into the process of things. I think some of that discussion was around these, let's say, very highly polished renderings that sometimes were either some people would criticize it being too hyper real or whatever, right? But I think at the same time, there was a period where a lot of discussion was about this sort of fetishization of the rendering, right? But I think in the same vein, right? There are also on the hand-drawn side, there's also kind of a fetishization of the hand-drawn drawing as well, and what it represents. And I think those two, I think generally, my sense is that those two things have slowly kind of come together and become less sort of oppositional.
Yeah.
And I think people are generally accepting the fact that, well, both of these things work. It just depends on the person, depends on the time and the place in the design process, what it can do. Because I think Dan, what you were kind of saying about in terms of using a screenshot, right, as a basis, I think I always kind of say that part of it is that it gives you a certain amount of accuracy, right, in dimension and proportions that are correct, and then sketching off of that, right, at least kind of grounds the hand sketch, right, to a certain degree. And I think that's a kind of really useful thing that it can do for you, and basically working back and forth. That your sketches, if you do the overlay, your sketches are kind of bound in a certain accuracy.
Yeah, and those overlays, it's like you're constantly trying to find it. You're working towards it. And you don't know what it's like looking like yet, and you're searching. And I like what you just said, because I don't have a great hand for sketching, but I have a good enough hand to communicate, and good enough to convey intention and design intention. But it's not going to be a beautiful sketch in the end, because the end goal is really to drive the design of the tower ultimately. So fetishizing or being obsessive with the drawing itself, I always look beyond that. So that was never really my take on things.
Okay.
Yeah, I think there's one more question, but I can't read it.
So is that Valentina's asking about Grasshopper and all these digital platforms as being liberating in the design process. Would you say it is easier with digital technology to create definition choice in particular moments within these curvatures or geometries? Or has the computer jeopardized the traditional form finding process by allowing architects to design in a world of dynamic entities?
So this is an interesting conversation because in Lead, unfortunately, I can't show you the options, but the lobby of this tower has there was 40 options that we made, 40 iterations of just the lobby. And it's because the client couldn't make a decision and we couldn't come up with something that the client liked. So one of the conversations after the fact, once we got a decision with the design partner, Gary Haney, on this project, which, I worked for him on this project, we were having this conversation about the feedback loop of the design process. So I showed you that picture of the 1970s SOM. Drawing by hand takes you 2 days to do a detail or a sheet or whatever. If you're going to take you that long to do, you're going to think really hard about what you're doing. Likewise, when I was at UF very early on, we used to do these hand pochés, hand rendered drawings, beautifully crafted. Well, you thought very critically before you start, because you have to plan a lot and you have to plan all the time you're going to invest in drawing that. Well, with renderings and rendering platforms and Grasshopper and all this, the feedback loop is shortened, right? So the amount of time that you may have spent thinking critically about what you're going to do is now shortcut by the fact that you can print the model, you can print the design pretty easily, or you can render what you want. And is that a good thing? Is that maybe allowing us to do more than we should? Just because you draw it doesn't mean you should, right? So it's an interesting discussion, and I don't particularly have an answer for that. But what I would say is that because I consider myself to have a strong foundation from undergrad, from UF, where we sort of had to do things thinking very critically, producing by hand. We didn't have laser cutters back then, so everything was cut by X-Acto blade. So it took a long time to make physical models, to cast concrete and all that fun stuff. Because it took so long, it taught me to learn critically about what I was doing, at least at the time. And I think I took that onto grad school. So when I finally had access to laser cutters and 3D printers, I sort of had a different perspective. So I don't think it necessarily erodes any part of the design process or opens up sort of a floodgate of bad design. I mean, it kind of did in the early 2000s, but I think it just depends on how you ground the design and how you actually make sure that you're not, like for example, this tower is grounded on a structural principle. One museum mile, I'm not sure. I haven't talked to that team about it, so I don't understand it as clearly as I would understand this project. So anyways, that would be my take on it, on that particular conversation.
Yeah, but and it's also kind of interesting because, like you said, in the early 2000s, there was a lot of what nowadays I would call bad, right, digital architecture. And
Architecture.
Yeah, the blobs. But I think nowadays you kind of look at it and say, okay, yeah, no, the entire industry has learned, right? Like all of us have learned how to kind of actually bring these tools under our control, right? I think there was that phase where more often than not, people were under the control of the tool.
Yeah.
Now flipped. Yeah.
Yeah, that's exactly right.
Maybe last question here. Mira asks, do you think Grasshopper Rhino will become more prevalent across all firms in the future? Today, it seems to be mainly used in schools and larger firms, but I wonder if it's something that will gradually become more mainstream.
Yeah, it actually, I would say it is. I think, at least in New York, even the smaller firms are operating with Grasshopper because the beauty of it is the most accessible way to venture into parametric design. Obviously, if you're going to pursue, let's say, residential architecture or something like that, where Revit is the main platform, well, the conversation's different. But it's a thing that can liberate you because it can extend your abilities 1,000, 10,000 times. Like imagine a perforation pattern on some kind of panel that, you know, is designed a certain way. Imagine doing that by hand versus imagine, you know, planning that parametrically. So it gives you the ability to work at the capacity of, let's say, 100 architects at once versus one, because you can create a tool that can expand your capabilities. So I think it is, at least in New York and some of the bigger cities where there's a lot of firms, there's a lot of us here, it's pretty prevalent. And even across the world, I would say, like, you know, some of the most notorious firms, even thinking of Japan or folks in the Netherlands, you know, it's something that's going to be useful.
Which the patterning thing you guys know how to do, right? You guys remember, okay? And those are like basic tools. Just a quick follow-up. How are people in SOM kind of distributed, or how does the system work? I think a while ago, you guys had kind of the computational team and then ambassadors that were embedded inside design teams. Does it still work that way? Or?
Yeah, I think now, because rendering platforms have changed, you know, there used to be the requirement back in the day to have somebody that knew how to create an image very easily. Now, because of Enscape, I think everybody has that capability. So I think teams are distributed by, well, it is a partnership. So it's not like there's a CEO or anything. And that means that the partnership leads the firm. So there's design partners and managing partners. And typically for a project like this, there will be a design partner, a managing partner, and then a senior designer like myself. And myself and a team, we would work collectively, you know, to sort of realize this project. And on this particular one, there was no real specialist, with the exception of, I would say, Song, who is the talented individual that put that animation together. And he basically managed the geometry. So he was the keeper of the Rhino model, the grasshopper model, and he was the keeper of what came into Revit. Because ultimately, this model was recreated in Revit through the smart paneling techniques, and using Excel to be the bridge between Grasshopper and Revit. So yes, I think, Lee, for something like this, you will need somebody that's going to be geometrically the sort of the keeper of information and making sure that everything that's feeding into the model is correct.
But you guys still have a kind of focused computational design group that helps with creating tools and things that the entire firm uses?
Yeah, and back to the specialization question earlier, I think that's definitely an avenue for people to take, because there's a group in Chicago called Black Box, and they design tools that are used at various scales, not only for towers, but also at the urban planning scale. And in New York, we have Digital Design, you know, Neil Katz, who I co-wrote that article with, you know, he's a big leader in that respect. And he made a tool recently, or I would say last year. It feels like recently, right? Last year feels like a blur. But he made a tool that, you know, the New York City building code for setbacks is very complicated. So when you get a new lot, it's hard to understand what kind of building you can actually place in that lot because of the height restrictions, the sort of setback rules and all that. So he made a tool that takes the wall drum analysis, which is like a different way to analyze it, and he made it in Grasshopper. And it's very, very cool. So, and he can output, and he could look at any lot in New York City and tell you how high, what the setbacks are, and he gives you the envelope, like the volume that you can work in. So yeah, I think it's definitely an avenue. Specialization is something that is needed. And I think you're going to see more of a need in the future as things get more complex and larger and more ambitious geometrically, at least.
They'll learn, you guys will learn more about zoning envelopes in Design 7, hopefully in New York, not online through Google Maps. Yeah.
Lee, what level are you guys, Lee?
This is Design 6.
Okay.
Yeah, so D6 is sort of, the building projects, right? The more urban buildings. Yeah. Charleston, Savannah, right now, a lot of us are in different cities in Florida.
Very cool.
All right. Okay, I think that's about time to let Dan go, but please, let's all kind of give a round of applause for, volunteering his time and experiences.
Well, round of applause for you guys, because I know how hard it is to go to class over Zoom, or at least operate over Zoom. So hopefully you guys will be together in studio soon enough.
Okay.
Thanks,
Thank you.
Lise.
Thank you
Good
so
seeing you
much.
again, Lee.
Good seeing you as well.
Bye. Have a good one.
Bye-bye. Okay. All right. Any thoughts, observations? You guys are pretty shy. I thought you would be kind of more, it's alumni, right? It's not you. You came from here too. He came from here too, Now, I think it's there are viewpoints there that are interesting. I do kind of just like couch it, right, or frame this presentation that he has a very specific job in the realm of design, that like these are corporate firms that tend to do larger projects and towers and things like that, right? So his viewpoint is coming from basically a tower designer, right, at this point. And I think as a larger firm, right, SOM obviously is one that kind of invests in technology a certain way, and kind of this is towards me question earlier about how broadly I think it will. And so I think one thing is that for them to adopt a parametric framework like this over a project like that, I think basically you'll kind of understand that like it requires projects of a certain size for it to make sense, right? That like investing one person to do all this for a project, to manage all that over the design lifetime of a project, the project has to be big enough, right, to kind of justify it, right? As a specialist. But I think there are other firms, smaller firms or kind of boutique design firms that are also using it in pieces, meaning that they might not do it for the entire design project or kind of managing everything, but they might do it for, a wall, right? There's a feature wall that we want to do some kind of perforation pattern on, right? Or there's some kind of crazy stair that we're trying to figure out, right? There, you'll see that the smaller design firms basically use it in little portions here and there, while the rest of it might be kind of more traditional, right? Or in a specific case, if they had some kind of facade system that we're trying to figure out, then they might use it, right? So I think that's where I would kind of say that it spreads, right? And it's a sort of more comparatively easier way to get into it because you see geometry, like you see things, right? I think again, he kind of touched upon this a little bit, but I remember, right, basically at the beginning of this course, I told you guys, right, that the goal of this course is not to make you guys into the expert, right, but at least give you enough literacy that you can understand when you see certain things that, oh, they probably did that, right, or they probably did this, or this is a Voronoi project, right, this is a whatever project, right, you can kind of have that idea and you have a basic general notion of like how the process works, right, so that you can interface with it and you can know basically how to work with it. Other thoughts, ideas, observations?
Do you think that because SOM and maybe other firms that are architecture plus engineering firms are more oriented towards like digital architecture like that, opposed to just architecture or design firms?
Well, not necessarily, because I think what you'll find is ultimately all these firms have to deliver documentation that is digital, right? Like even if you had a smaller firm, like it's the drawing portion, right? Or whether it's like traditional or not, right? The drawing portion is kind of more in the design process, but eventually the delivery of, the final, let's say, design DD documents or construction documents, those are all digital now, right? regardless whether it comes from Revit or AutoCAD or whatever, right? And I think in their workflow, right, and this is most big firms, basically, I mean, I would say almost 100%, including Zaha, right, a firm like that, where Revit is kind of the endpoint, right? And so I get this question from a lot of you often, right? That you ask, well, I know because in our curriculum, you either have a choice of advanced digital or Revit, right, or BIM, right? And I always say both, right? You kind of want to take both, whether it's the this semester in advanced digital and then BIM in your final year, right, or vice versa. Because I think for me, from my viewpoint, right, Grasshopper is more of a design tool. Revit is a documentation tool, right? Those of you who have done Revit before will know that it's a really crappy design tool because it forces you into boxes, forces you into thinking the way the program wants to think, right? And I can spot a Revit project like from 5 miles away, right? Because it's just so obvious, right? Now, the Revit, the Grasshopper part is not as good as in terms of like basically spitting out construction documents and things like keeping things aligned across different floors and whatever. So I think ultimately, like you'll find that you probably need to do both, right? One is much more on the design side, one is much more on the documentation side. Because like the way Revit works is a lot more rigid, right? But it can be super helpful or useful once you know what you want, right? And it will take care of a lot of like interesting or weird intersections, keeping your floor plans aligned, keeping your elevations up to date. That's that sort of thing that used to be when I made a change, right? And I had to kind of update all the different elevations and all the things that human error happens, right? So Revit is a great tool for that in that sense.